Well, hello friends. Today we're going to work on another bug, and this one is almost a week old now, so we should take a look at it. It's about modal dialogues and how they don't lock the main Windows menu. So basically, when you bring up a modal dialog somewhere, then it's still possible to interact with the application's menu. Now, that's probably not what we want. So let's see, like if you bring up this color editing dialog here, then we can still interact with the menu, which is weird because we can do this, and now we still have this guy, and now cancel doesn't work, and everything just falls apart. So we should just not allow this. All kinds of problems here. So of course the correct behavior is that we just, I'm not sure exactly what the correct behavior is. So he says this is confusing and probably wrong. Yeah. So macOS shows but disables the menu. I think that would work for us. So let's see, how is this working again in the Windows server? We have is modal something like that? Yeah, so you could check if a window is modal, and if so, we could just let's see, where is this used? Is modal? Is blocked by modal window. So is blocked by modal window, that's like if another window is blocked by modal window in the same process. Here is showing modal window. Now this is the one that we're interested in. So if we are showing a modal window for a Windows Server client connection, then we want to disable the menu for that process. I mean the menu at the top of the screen. Should still be allowed to have context menus inside of a modal window. Anyways, so let's see. Right, so I haven't looked at the Windows server for a while, so how do we do this? I guess when we want to interact with the menu, menu, somewhere in the process mouse event maybe. Right, so this is where like every mouse event ever comes in through this funnel here, or this, whatever you call it. So this is like where this is where everything happens for the mouse events. So this is a good place to start looking, basically. That's what I'm trying to get at. So I guess when it comes to the menu stuff, so here is where we pass it to the menu manager. So like if the event is within the menu bar rect, which is like the rectangle at the top of the screen, it's just very simple like this. But then we could say that for this case, menu bar rect, I guess we should just not care about it if the currently active window is modal. So let's see, if currently active window is modal, modal is active window, and active window is modal. Does that make sense? So I think that will make it so that it will no longer care about incoming events. But let's see what it actually feels like, because I think we should also close any like already open menus by the time we bring up a modal window in a windowing client. So let's see here. So menu works, and then control click on one of these, and menu still works. That's not entirely right, although it is working weirdly because I can't switch between them. But I can still click, sort of click. Okay, that's really strange. Excuse me. Okay, let's see. I guess we can do this. Currently active window is modal. Just so we can learn that. And because we are getting that mouse down and it does seem to go through, but why is that? Why is that? Okay, now we have this spam down there in the debugger. So clickety click. Now the currently active window modal is true. Okay, so it is true, but it still allows me to click on these, which is really strange. So current menu. Oh shit, I guess, let's see. The current menu is, jeez, I forget what the current menu means in this context. I think it means like which one is open in the menu bar. I think. Set current menu. No, even if we do a pop-up, then that becomes the current menu. So it's whichever menu is currently open. Okay, so handle menu mouse event. And menu manager event. That's weird that we would get there, but okay. Handle menu mouse event. Okay, this one is no longer relevant, so let's just get rid of that. This one is also no longer relevant. Seems like we had some leftover function declarations there, but now we're rid of those. Okay, so let's see where this is actually used. This is only used in one place, which is really weird, because I would expect us to not get here, but okay, let's just say handle menu mouse event. Set current menu. I'm going to look for that, and set current menu bar, that's not what we're looking for. And here, okay, well, I mean, it really does seem like we're ending up here, even though we're not supposed to, so should check that out. Unless we are going via the this route here, which is WS menu pop-up, which should only happen for context menus, so I'm surprised that we would be there. Alright. And handle menu mouse event. Click. Yeah, we are getting handle menu mouse event when we go up here. Well, why is that? Currently active. Oh, why? Okay, I'm stupid. Okay, it's early morning here. Give me a break. are we here? I mean, this is also weird. Right, so it's not modal, but it becomes modal. Okay, so it's not that I'm stupid, because we're not printing that I'm stupid, but we're still getting handle mouse event. Well, I guess we can just go and handle mini mouse event. Oh, it would be nice to have a backtrace here, but I don't actually have a way to get a backtrace without crashing. And I don't really want to crash right now. Since we do control the kernel, we can just add a way to give us a backtrace, I guess. So we'll just make a new syscall. Dump backtrace. Can we do that? Freaking Clang format. Alright, we'll do that, and then we will just add it to the, what's this called, dispatch function. And this looks messy, so let's just clean that up. Sorry about that. I mean, actually, no, I don't want to touch it in dispatch. But it does look messy, so we should fix it eventually. Dump backtrace. So dump backtrace. Okay. Then we'll just put in voids is dump backtrace. And it will be implemented very, very easily. Dump backtrace. We'll just call dump backtrace. Beautiful. Okay, and then in, should we just go unistd? I'm thinking we put it in serenity.h because I never put anything in here. In fact, I should maybe just get rid of that one, so we'll just go with unistd for now. I forget what I said. Oops. And void dump backtrace. This is called dump backtrace. Okay, I think that was everything that we needed to dump the backtrace. Cannot initialize it like that. Oh, I'm sorry, dude. Okay, well, it should just return an int then, I suppose. So, because it's always going to succeed. Dump backtrace. Alright, there we go. And where was that handle menu mouse event? Right, so dump backtrace. We'll do that there. This is gonna get spammy. But it'll be nice to have a way to dump backtrace from user space. I don't know why we didn't have that before. I have to rebuild everything. I guess it's because of unistd.h, obviously. Come on, bro. We're almost there. And syscall.h, for that matter. I put a thumb up on this bug in the meantime. Alright. Oh. Oh, look at all those backtraces. It's so fucking cool, actually. Okay. Alright, so let me open this thing up. Okay, so now it's modal. We shouldn't be here, but we are. So why are we here? For each visible window, process mouse event, deliver mouse event. window event, menu manager event. So in deliver mouse event, WS window event. What? I mean, these are a little bit hard to read. I should really make I should make a demangler. I keep saying I should make a demangler, but I really should. Okay, so this is the readable version of the backtrace. Or actually here is where we are. WS window event. Wait, why did it show up so weird? Dang. No, I want the whole thing. Catch, dang, like that. Okay, this looks right. So we're in this guy, and he calls menu manager event. Well, that's really weird. Event. Wait, do you have the implement event? Yes, here we are. Deliver mouse event, and then we call internal owner event. Is that what's happening? Quite early in the function, we're just 34 bytes into it. So who is our internal owner? Well, the plot thickens. And then we create oh shit. Yep. This is why we're here. Right, now I remember that the menu manager, it makes a menu bar window nowadays. I totally forgot about this. I did this in a video a while back, I think, but I don't remember. That it used to be that the menu bar didn't have a window, but now it does. So obviously we're going in through the menu bar window. Damn it. Okay, that was stupid. So that's why we're there. And then the internal owner is the menu manager, so he ends up with the event anyway. All right. Well, that explains it. So then we go here. And that's how we get there. So let's see. Menu manager event. So I'm thinking that in these cases, we don't want the menu manager to allow you to interact with the window either. So the easiest way to do that is probably to just ask the window manager if the currently active window is modal. I think, yeah, that'll be the easiest. So that would be something that we do here, really. So if WS window manager the active window. Oh, hold on. Let's see, auto active window is that, and we'll say active window, and active window is modal. I'm trying to get used to writing if statements with these initializers or initialization lists. It's very nifty, I think. Although it's kind of it's a little bit, feels a little bit weird that you have to check the condition, like, because in this case, the way that I used to do it, it would be implied that like this has to be a like a true statement. So like if this were null, then we would not enter into the scope. But now this here is just an assignment, so then we have to actually check it. But I think it's still very cool. So okay, what is it that I want to do? Just return, I guess return this. Should be a good boy here, and defer to the parent class, because we inherit from C object, right? Okay. Put you away. Okay, so now if we have an active window and it is modal, then we will ignore, right? Okay, this works. Let me click on here, and now this thing up here just does not work. Very cool, actually. So, and then if we close it, and everything falls apart. Why is that? M blocker, blah blah blah. We just die miserably. Read from a null pointer. I feel like maybe these are. We just hit a cascade there of bugs that are not related to what we're working on. Things that we should be fixing, obviously, but probably not in this particular batch. Okay, so closing that window does not work. Jeez, well, why is it like that? Null deref here in Paintbrush. I guess we gotta look into that. Although, hold on, let's commit syscall stuff that we did. So, libraries, let's see. Let's do a patch review for just that stuff. So here's the implementation of the syscall. It just calls dump backtrace, return 0. Here's the process class declaration of the function. Here is where we dispatch it from the syscall table. I'm just adding it to the list. And here's the libc implementation. And actually, we should probably be good here. And or I mean, it doesn't really matter. Dump backtrace. I was thinking like we should have a return value, but we don't care. Yeah. So let's just commit this. Oh wait, hold on. What the hell am I doing? Oh shit! Now I added a bunch of stuff that I don't want. What? Yeah, these are the things that I want. Kernel plus libc, add a dump backtrace syscall. This is not very simple, but already very useful. It allows you now you're able to call to dump backtrace from user space anywhere in user space to get a nice symbolicated backtrace on the debugger output. Oh, that is very nice. Okay. And just to orient ourselves, what do we have here so far? A bunch of gunk. Alright, and then just remove this right away, because I think this logic here is sound, but it is a bit concerning that we're not able to close that thing. So now that I've touched things a little bit, let me just rebuild. Alright, maybe I didn't touch things actually. I'm just paranoid. I want a fresh pointer so I can start looking into the disassembly. And you come here and then cancel, and then what's the first problem that we see? So okay, so we have a null deref at this address right here. So it's in C event loop pump. Alright. And where exactly? We gotta look into that. So grab this, and then we will do an obj dump of, what was this? The paintbrush. Oops. And then we search for that, and here we are. Okay. So what is this code? Like usually when I'm trying to orient myself in some disassembly like this, I just look for like calls nearby. So there's a debug printf, and there's a vector at, and there's a donate here and a clock unlock. Donate. So I know that donate and clock unlock, that means that we are nearby the locking mechanism. So that would be there or here. And here is close to the end. So is that where we are? So I guess not particularly close to the end. Oops. But are we close to the beginning? Kind of, sort of close to the beginning. Alright. Okay, let's have a look here. So, where's wait for event? Wait for event is here. It's this guy. Probably there's some tool I could be using for this, but I don't know. Okay, so here's the lock. This locker right here. Start by doing getted. Blah blah blah. Here's the assignment operator. Operator equals moved. Yeah, that's that one. Then the unlock is exiting the scope. And then donate. It's still exiting the scope. Blah blah blah. And then at. I guess that's probably this iteration right here. Okay. Alright, so probably we're walking this list here, and we have a null pointer in there. Can that be it? Where are we? So this is where we're crashing. Or no, here. So we're fetching something 4 bytes into EDX. And what's EDX? It's from here, 4 bytes into EAX. And alright, so let's see, let's do debug. Let's do it this way. And then we'll say auto queued event at time. I and queued event. And then we should be learning if any of these are null pointers. So we have a lot of stuff going on in there, but we'll crash, and we shouldn't have so much going on. Or did we? Possible null pointer deref. Oh wait, that's not the right file. Let's start over. So now this is the debug printf that he did, and then we crash right after. Dot receiver. Receiver putter. Wait, that's weird. Why is it like this? Let's print out the PID. That will help us orient ourselves. Get PID, get TID. Do it like this. And we have both the process ID and the thread ID, so we know exactly where we are. And then we can also do the queued event receiver. Yes. It's going to get extremely spammy. But and then also this. And all right. I don't know if we could possibly get more spammy than this. Get TID. What do you mean no get TID? Of course get TID exists. Get TID. Why don't they see get TID? What the heck? What? Oh, 1, 5. I'm so confused right now. Oh shit, wait. This is in the, oh fuck. This is, we're compiling for the host system here. Oh, so we can't use that because it's, but we could use it here, systypes.h. Okay, so Linux does have it, so, but it does feel a bit cheaty, but we can, systypes.h. Okay, well, I don't want to screw with this right now, so let's just say that we don't do getTid. Yeah, I forgot that getTid was not, or rather I forgot that cEvent loop has to compile on the host as well. So screw it, we'll just not print the thread ID. Because there's only one thread in this program that we care about anyway, so it doesn't really matter. So I'm wondering if it's going to be that the event pointer is null. I'm not really sure what it is. Okay, my extremely spammy friend. Paint a little bit, okay. And then cancel. And then watch it all fall apart. This is where we crash. Or no, here's where we crash. 13. The receiver putter is 0. And the event is 0. Right, but then the receiver is null. Oh, wait, what's going on here? The receiver is null. So we should be in here, I would think. But then we're also trying to... oh, that's so weird. So we don't have a receiver, but the event is gone. Why is the event gone? That doesn't seem right. So we're ending up debugging something entirely different from what I started out on here, but I think that's okay. So normally what happens when you exit a nested event loop is that we get down here and then we take whatever events the nested one hadn't processed yet, and then we add those back to the queued events. Because I guess the relevant part here is that when we enter pump, this is where we're going to process all the currently pending events, basically. And what we do is we make a local copy here of the event queue, and then we go through the local copy of the event queue, one event at a time, and process those. But if we are asked to exit the current event loop, then we take whatever events we have here and put them back to the front of the queue. Although that's a really weird way of doing that, now that I look at it. Because we are putting events that we may have already processed. We should probably only be putting the events that are not processed. So if we've done 3 of them or whatever, we should only put the remaining 2. So this logic here seems a little suspicious, but also it is weird that that the event itself was null. This event here is null. That's why we're crashing, I think. So we can probably make the crash go away by doing something like I don't know, like if event, I'll do like null event with no receiver, something like that. Else, oops, debug, and type, and type, no receiver. Queued event, type event. Actually, we can just skip over it all the way up here. So if queued event dot event. Null bug null event in queue. That's a bug, and we can just ignore it for now, but it's something that should be fixed eventually, so I'm going to leave a fix me about that. And I spotted all kinds of little issues there to work on, but I'm gonna try to actually finish what I started on here. So let's see, let me cancel that. We're still good. Okay. So now you can't interact with the menu, and when you cancel this guy, then you can interact with the menu. Very cool. Okay, so let's see, we can try to calm down all this spam here. And just do that. See what we have in that change in libcore. So I think I'm just going to commit this as a separate thing. So I'll say C event loop, skip over null events in that queue. Oh shit, and actually I want to add fix me down here as well. Shouldn't we only prepend processed yet? Okay, and then we'll add that again and amend. Okay, so we'll say also added fix me's, added some fix me's about correctness issues with nested event loop exit. Okay, yeah, because then we don't have to work on that right now, and we can actually continue working on our Windows Server stuff. So let's actually do a patch review of that. So I'm doing this to remind myself, by the way. It's like I'm trying to NLP myself, if you will, because I don't want to forget to look at code before I commit. So in Menu Manager event, we check if there's an active window, and if it is modal, then we ignore the event in the Menu Manager. That was that thing where we would end up there because the Menu Manager is the internal owner of the menu bar window. Anyways, and then here in the Window Manager, at the central mouse event processing, we also check if the currently active window is modal. So maybe actually we should, because these are the same things, right? So we should just make a helper for that. That would be slightly nicer. So we'll say, where's the active window? Where are you? Here. Okay, active window, active client, and we'll add active window is modal. Turn M active window and active window. Why does that not work? Because const? I can't do that. Okay, well, that's fine. I'll just do it that way. And actually, I think we can live without that no line. Okay. And then in Menu Manager, CPP, we will, instead of doing this, we will do if ws window manager, the active window is modal. Plop. Much nicer. And currently active window is modal. Then we don't have to say it in this confusing way. We can just say if not active window is modal. Cool. See, now this is much easier to read actually. So if the active window is modal, then we ignore the event. Down here, if the active window is not modal and it's within the menu bar rect, then we let the Menu Manager manage the mouse event. This is actually kind of interesting because maybe maybe this part here is not actually even needed. Like, if we remove that, will things keep working? I'm kind of curious now. Because now that the menu manager exists, why would you need to special case the menu bar here in the central mouse processing stuff? Like, maybe it will just come in the right way anyway. Let's have a look. It's not really behaving the way I expected. Like, it doesn't let me like drag between the menus like this. So I think maybe I'm not going to touch this in this particular batch because we're already all over the place here. So yeah, this still works. Okay, so apparently we need this for some reason, but let's put a fix me. Now that menu bar has a dedicated window. Is this really necessary? Is this special casing necessary? Yeah. Okay, so where were we? Right, and then here's the implementation of active Windows modal. He's just very, very simple, right? And then we removed two unused functions. I think that's good. So let's say window server disable global menu bar while a modal window is active. This makes it much harder to screw with an application while it's showing a modal window. And sort of, and it matches some other systems are doing. I mean, not that that's a goal in itself, but you know. Okay, cool. Let's push that and see it one more time. Shit, I forgot to say fixed in, or fix this. Damn it. I have to do it this way. I still like it when I remember to do this. So fixed in. There we go. Cool. So I think that's pretty good. Let's just try it here. And don't worky, cancel, and totally worky. Okay, very cool. Right, so I guess that's going to be it for today's video. So if you made it this far, then I thank you for watching, and I hope you saw something interesting, and I will see you next time.